Please open in your learning workbook to page 189 and read along as we learn together. Convert between logarithmic and exponential forms. When you see a to the y equals x, think, what's the exponent? And then write a sentence. Y is the exponent that goes on base a to make x. Notice the EGOB built into that sentence. So we can write this symbolically as y equals EGOB a x. Then we remember EGOB is the same as log, and we can write y equals log base a of x. Now, put together the things we started with and the things we ended with. A to the y power equals x is the same as the equation y equals log base a of x. This gives us a very important relationship. A to the y power equals x implies y equals log base a of x. Replacing the symbols a, y, and x with colored shapes gives us an important conversion tool, which I will refer to as the converter. All right, we now have the following statement. Log base blue box of red circle equals green trapezoid is the same as blue box raised to the green trapezoid equals red circle. Now each of these colored shapes gets a name, a math vocabulary word. The blue box is the base. Notice that those all start with the letter B. The red circle is called the argument. The green trapezoid is the exponent. Now I'd like to share two comments with you about these names. First, argument is a term we've heard before. Earlier this semester, we learned the 4 steps for finding domain. Step 3 is that a log argument must be greater than 0. We now know what that looks like. An argument is the thing you're taking the log of. Second comment I would like to make with you is it's pretty clear that this is an exponent. It has a base and it's raised up into the air. But this may not look like an exponent until you remember an important phrase that I've shared with you several times. A logarithm is a missing exponent. So log equals exponent makes sense to us. All right, so now what we're going to do is we're going to practice our vocabulary words. I'm going to point to a colored shape, and I want you to say out loud the name of that shape. I will reveal the correct answer about a second or a second and a half after I point to the shape. And I will go faster and faster. See if you can keep up. Let's begin with this one. Base. Exponent. Argument. Base. Exponent. Argument. Exponent. Base. Exponent. Argument. Base. Base. Exponent. Exponent. Argument. Argument. Base. Exponent. Exponent. Base. Argument. Exponent. Base. Exponent. Argument. Okay. Hopefully now you know the vocabulary words associated with the anatomy of these two sides of our converter. Now let's put it into practice. We will find that in this class it will often be convenient to take an equation in logarithmic form and rewrite it to be an exponential form. Or we may find that we have an equation in exponential form that we would like to rewrite in logarithmic form. Converting back and forth is an extremely important skill. Let's learn it now. Example, write each equation in exponential form. Part A says log base 2 of 16 equals 4. All right, because the equation we are given has the word log in it, we start on the left side of our converter, and we fill in the colored shapes. The base 2 goes in the blue box. The argument 16 goes in the red circle. The exponent 4 goes in the green trapezoid. Now match up the colors and shapes on the right side to get the exponential form of this equation. If there's a 2 in a blue box on the left, then you put a 2 in the blue box on the right. If there's a 16 in the red circle on the left, then you put a 16 in the red circle on the right. If there's a 4 in the green trapezoid on the left, then you put a 4 in the green trapezoid on the right. We now get a new version of the equation we started with. It is 2 to the 4th power equals 16. We've now taken our logarithmic equation and written it in exponential form. That is the answer to this question. 2 to the 4th equals 16 is the answer to this question, because the instructions say write in exponential form. By the way, this is a true statement. 2 to the 4th power really is 16, and therefore log base 2 of 16 really is 4. All right, let's move on to part B of this example. Log base 10 of 1 over 100 equals negative 2. Once again, our equation has the word log in it, and so we start on the left side of the converter. Log base 10 of the fraction 1 over 100 equals negative 2. Now match up the colors and shapes, filling in the right-hand side of the converter, and we get the exponential statement 10 to the negative 2 equals the fraction 1 over 100. This is our answer. 10 to the negative 2 equals the fraction 1 over 100. We have converted from logarithmic form to exponential form. Okay, let's try another example. In this example, we're going to be given two equations in exponential form, and we are asked to convert them to logarithmic form. Let's begin. 3 to the 4th power equals 81. Notice this equation does not have the word log in it. Therefore, we start on the exponential side of our converter. The base is 3, so it goes in the blue box. The exponent is 4, so it goes in the green trapezoid. The argument is 81, so it goes in the red circle. Now match up the colors and shapes. On the left side, we get the following. Log base 3 of 81 equals 4. Our final answer is log base 3 of 81 equals 4. We've converted from exponential form into logarithmic form. Okay, let's do part B of this example. Part B says the fraction 1/5 raised to the negative 1 power equals 5. Once again, there's no log in that equation, so we start on the right side of our converter. 1/5 raised to the exponent negative 1 equals the argument 5. Now match up the colors and shapes. On the left side, we get log base 1/5 of 5 equals negative 1, which is our final answer to this problem. Log base 1/5 of 5 equals negative 1. We have converted from exponential form to logarithmic form. Remember, a logarithm is a missing exponent.